Hello and welcome to the continuation of Lesson 1, CE 3372, Water Systems Design. This next section is a little history of water systems of interest. It's adapted from Historical Urban Water Systems created by Dr. Robert Pitt at the Department of Civil Environmental Engineering, University of Alabama, Tuscaloosa, Alabama. God, it must be 10 or 15 years old that he did this as part of one of his classes, similar title. As we proceed through the history, consider whether the picture is a water control, water use, or environmental restoration system. So here's our first picture. There's a set of, it's the same spring. It's located in a place called Delphi, Greece. And back in the olden days, there was an oracle at Delphi, Greece. The Oracle was not the software company that it is today, and Delphi, Greece is not the programming language that it is today, although I'm pretty sure that both those names come in part from uh, ancient history. So back in the olden days, kings and queens and knaves and so forth would go to an oracle um, to get advice. So sort of like priests, sort of like financial advisors, and basically, if I take these 300 Spartans, am I going to be able to open a can of whoop ass on the Persians or not? And the oracle said, well, I don't know. So they give him some money, and then pretty soon, yeah, you guys will be fine. Go for it. In the meantime, the oracle gathers up all of the all of his pals and says, yeah, we got to get out of here. This is going to go bad. So back then, clearly there was a community built up around this location, and the size of the community was certainly controlled in a large part by how much water came out of this spring. And the oracle and the oracle's lieutenants um, uh, would have built their consulting firm on top of these springs. So that was clearly a water use system. In modern times, obviously, whatever ancient stuff is gone. It's all washed away with time. There's still a natural spring bubbling out of the ground, and people go and they bring their water bottles there and they drink the water from the ancient spring, and that makes them closer to ancient history or timelines or stargates. Who knows? Okay, here's another picture. Left one again is from ancient old time Greece, and you see these stones here. I'm moving the cursor over the stones, and they're clearly so that you can walk over this little channel and not get your feet wet, or togas, although I think that's Roman. Anyway, here's another view of a similar thing, again stones over it, and more importantly the channel here is clearly an engineered rectangular channel, and you can cross there and again you don't get your sandals wet. Move to modern times, and except for scale, except for the size of things, we have a nice engineered channel, engineered channel, engineered channel, and we have a stone laid over the top to cross the channel. In this case, it's a bridge deck with a motorway on it, and we hold the things up with these little sticks that are called pilings, and our channel is no longer a rectangle, but a trapezoidal channel. But clearly, it's lined with rock. It's lined with rock. It has a passageway over the top. Has a passageway over the top, and it's designed to carry water as well as human activity. And this is clearly a water control system. That water is storm water or drainage water. And remember earlier on we said that drainage engineering is indicative of water control systems. Interestingly enough, the technology hasn't changed much. Slave-hewn rock versus liquid rock, and bridges to go over the channels. Okay, moving right along, we have a photograph here on the left, and if you look carefully at these stones here, there's cutouts that look remarkably a lot like keyholes and or toilet seats. And sure enough, that's what they were. Instead of putting Homer buckets there, you'd do your business, and it would go in this trough, and it would be collected, and then there would be toilet seat slaves who would take the feces, which was useful as fertilizer. It's called night soil, and then the urine would be collected, um, evaporated to produce uric acid, which was used in setting dyes. So both those were actually valuable resources, and people not only paid for the privilege of delivering the resources, the kings and queens or whoever ran things back then resold the resources to the same people that just paid to give them the resources. Pretty good um, circular economy there. Here's another view. This is in part of Seattle, and the toilet seat is raised relative to the surrounding ground, and that's because close to the waterfront, the actual water lines would otherwise be below the hydraulic grade line, and so the water wouldn't flow away. And so they had to you have to elevate the water system so that gravity drainage can occur. And then this right one is supposed to depict an open sewer in comparatively modern times. You know it's modern because you got wires here. These are becoming globally. I think there's fewer and fewer open sewers, but it's by no means a solved problem today, and there's still plenty of work to do. Either close the sewer, or I guess we sew up the cheeks of the people that make poop. Moving along in our water system design, we look at that's a water use system. We're using water to support human habitation. Moving along, we can look at some different materials that conduits have been made out of over the centuries. Uh, Back a long time ago on Minos, Crete, people would be born into a family of pipe makers, and when they got old enough to handle a chisel, they'd be given a rock, and they would chisel out a 20-foot length of pipe. They'd be 32 years old and die of old age, and then keep passing the trade on. So it took centuries to build pipelines out of rock. I'm exaggerating there, but this pipe is cut out of stone, so it had to be either soft stone or very hard people to create these pipes. And interestingly, technologically, it's very much like a pipe today. It has a spigot and bell, and they're pushed together, and there was probably some material in there that formed a gasket. It wasn't rubber, hadn't been invented yet, but I don't know, maybe it was the king's wife's cooking. That's a diss on their cooking skills. Someone who couldn't cook went ahead and made bread, and they put it in there, and that took care of it. In a different part of Greece, this group, they were a bunch of people that made stuff out of clay, and so when they weren't making pots and dishes and other little clay items, someone had the good idea, well, let's make pipe, because I'm tired of cutting pipe out of stone. That's hard work. And so they'd make these coils of clay, and they would become they'd fire them and make lengths of clay pipe. Interestingly enough, clay is still used today. Probably slightly more advanced technology to fabricate vitrified clay pipe, but same idea. Make the pipe out of clay, you fire it to give it certain properties, material strength, as well as corrosion resistance, and clay is very corrosion resistant, and it can be in use today. There's less and less pipe today out of clay because there's actually a high level of skill need to lay the pipe in the ground, and that skill set is fast leaving our collective knowledge base. Okay, so ancient pipe out of rock, modern pipe out of concrete, solid rock, liquid rock, ancient pipe out of clay, modern pipe out of clay. In Rome, they made pipes out of bricks and mortar, and so these pipes are shown here in some part in ancient Rome, and interestingly enough, even up into relatively modern times, large diameter sewers were constructed literally in place out of masonry and mortar. Again, that's now being replaced with plastics and concrete. This technology, 100 AD, hasn't effectively changed to date. In London, they made pipes out of lead because it was easy to work with, but it made them nuttier than fruitcake, or madder than a hatter. I'm not sure which. And the lead pipe initially sounds like it's a horrible idea, but an oxide forms on it pretty quickly, and as long as the pH and salinity of the liquid in contact, if the pipe's being used to provide drinking water, isn't the worst thing in the world. I wouldn't personally want to drink it, but there are worse things you can do. As soon as you get those pHs and salinities wrong, then the lead does get released into the water, and that's what happened in Flint, Michigan recently. In Seattle, materials other than wood were hard to come by, so they just made them out of wood. And here's a wooden water pipe, circular interior, square outside. This is one of the few times you're going to see a round hole in a square peg. And one of the nice advantages of wood is first, it's easy to replace, but secondly, if you need to make a tap anywhere, you just punch a hole in it and the water comes flowing out the hole. And then when you want to stop that tap, you put a plug in it. And that plug is called a bung, and you can guess what the hole is called. Lastly, back to London, we have cast iron pipe, which is still in use today. So most of the materials represented in this photograph, with the exception of lead, are to some extent still in use today. So water systems are very old as far as civilization is concerned. Water has to be lifted from low elevations to high elevations. So one way to do it is with buckets. That worked, but it was slow and inefficient. So a faster way was to strap all the buckets to a wheel, give somebody an umbrella, and say, walk. And they would walk this wheel around and around and around and around, and it would lift water from one elevation to a slightly higher. Hopefully they're doing this here to water this field. This is a centrifugal pump that's not much different. It has little buckets in it, and they go round and round and round and round. Well, I guess I'm going round and round and round and round, and the water comes in, gets to the bucket, it's accelerated and spit out the top of the pump and goes on about its merry way. Back in the olden days, there were also these things called screw pumps, and here's a couple of screw pumps being operated by two pump screwers as a team. And this is rotated, and it gets a bite of water, and it lifts it up the screw flies and then drops it at a higher elevation. And modern mechanized ones are in use today. Here's a large 3-barrel screw pump system, functionally, technologically identical to the one operated by these two people, powered by diesel or electric, and lifting over greater distances and probably much greater volumes. Again, pumping is very ancient, or lifting water is very ancient. Last thing we do with water is we have to store it. So we can keep it in our little water bottles, and that's convenient for a day. But if we need to keep it for a long time, we either use bigger bottles. So here's some large bottles here. These are probably sized, and the lip is put on it so it can be carried by tying 2 sticks to either side of the lip and then putting it onto the shoulders of very strong yet unwilling people known as water slaves. So the original water boys did these big buckets. We also can build holes in the ground, but hole in the ground doesn't sound very exotic, so we call it a cistern. And then this one to the right is brethren. And these stairs are so that a person seeking water out of the cistern can go up or down the stairs depending on where the water level is. So when the water level comes up, you only go down a couple stairs and get it. As it drops down, you go down a lot of stairs and get it. That's to keep you from having to throw the bucket over there or, God forbid, accidentally kick it. We scale up, and here is a big cistern. It's called Lake Mead, and these cylindrical objects pulling out of it are actually vertical inlets, and they play the same role that these stairs do. They allow the water to be captured from different elevations depending on what the lake elevation is here. I have a couple of extra features. We have these side spillways, which are used in the rare event that the lake's going to get too deep, and they can be activated and water goes down this hole here and it disappears and it comes out these walls right here, and there's one right here. And this down here is a powerhouse, so instead of wasting the water by emergency bypass, it actually runs through turbines and generates electricity, and that electricity is important because this is located next to Las Vegas, and if they didn't have this Lake Mead and the hydropower, then the casinos wouldn't have flashy lights and go ding, 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 you're a winner. Moving back to our tanks, we can build them small. We can build them on the ground. So here's a ground tank. And if we want to get some extra pressure, we can elevate them in the air. So in addition to providing whatever this head is by elevation, it also gives us a convenient location to paint the name of our high school football team on. So this is Nasrallah, Iraq. I don't know what their high school football team is named, but if we went there today, it'd be painted on the tank. Okay, so this concludes Lesson 1. Next time, we look at land development vocabulary, design manuals, and project report. Most of the topic for the Lesson 2 is based on design. Where do you get criteria to decide how big you make something or what material you choose? Thank you for your attention, and have a good day.